Buddy, I was waiting for that little lip voice to come on and say recording. Welcome to the Virtual Night Sky for our second episode in August. And we have a little bit of a break in the monsoons. It's not as cloudy as it has been. I think it was a really beautiful night last night. In fact, I forgot to go out and look tonight, but I'm going to give you some things tonight to go out and see after the meeting. We're going to be here from about 7 to 8. We're going to talk about a couple of things tonight. I'm going to introduce the second thing first. We're going to talk about the Milky Way and the constellations that are within the Milky Way and some of the ways we see the Milky Way, not only scientifically, but culturally. And so it's going to be, that's the second section. The first section I'll introduce in a moment. And but before that, I'm going to introduce some of the team that is here. With me, staff members that are with me are Meg Hufford and Kim Baptista. You probably know Kim Baptista by at least her name. She's the one that keeps the communication going. She sends out the webinar information and the notices, and she's the one that will send you a survey after the show so you can kind of make some comments about what we're doing tonight and suggestions for the future. We also have some students that have been with us all the way along the way. I think we're in about 16 months of doing this particular program every other Wednesday night, and we're going to keep going as long as we feel like it. So Alicia Hyatt is with us tonight, and you'll see her a little bit later in the program, and Alex Blanche is with us tonight, and he will be here as well. The students will also be manning question and answer comments and questions that come through. So this is a webinar version of the Zoom, and so you can't chat. We don't allow that to happen, but you can ask questions. So the little question and answer button on the bottom of your screen, just push that, and you can sort of just ask a question along the way. It can be about what we're talking about, and Alicia and Alex will monitor those and make sure that they get answered. Also, we will take little question breaks. So sometimes we'll find one in that question sequence where we'll expose it to the audience and answer it online as well. So if you do that, that would be great. I hope that there's some students with us tonight. School is back in session. Summer break is over, and we do like to enjoy having K-12, especially elementary students, join us. And I know a lot of teachers follow the program, so welcome if you're a student and you do that. And if you want to ask questions, we don't need to know your last name, but we wouldn't mind knowing a little first name and what grade you might be in as we go along the way. We also know that there's some other groups that are regulars. I think Mirabella group is probably with us tonight. They like to get together in a big room and all watch the program together. So welcome, guys. I'm glad you're here. Let me see. I think it's time. Oh, I just should say something about closed captioning. If you want it, it's up to you. You can turn it on. You can use your own device to turn it on. If you don't like that, you can turn it off. We do use closed captioning in our YouTube videos, and this makes it really easy for us to package those and get them organized into YouTube. You will be seeing some resources along the way. So as I mentioned, YouTube, a lot of our programs are readily available within a day or two after the program. And there's a website where you can find that. And that website gets to you by virtue of your a thank you that goes to you after the show. And you can see it in chat right now. So that would be kind of good to do if you want to follow up and see again. One of the main features tonight, and this is really exciting, we have two guests, and they're from a center on our campus called Lunar Reconnaissance Orbiting Camera. And so I'm going to welcome Nicole Gonzalez and Gavin Sondrup, and they are actually coming to us from the lobby of their visitor center. So on campus, we have a couple of buildings. We have 5 buildings that are dedicated to space faculty and classrooms and Earth and space subject matter. But we actually operate out of about 7 or 8 buildings on campus. And LROC has a building of their own, and they have a little visitor center, and they have a great place to go visit. So as we get organized to have visitors back on campus, just put that one on your list. You're going to have to go. And in a moment, you're going to see why. So I'm going to turn the microphone over to Gavin and Nicole, and they have a really special movie for a very special reason that they wanted to share with you tonight. Go ahead, guys. Welcome.
Thank you, Rick. It's great to have everybody here. Hello, everyone. My name is Nicole Gonzalez. I'm a grad student here at LROC, and my work focuses on the Apollo missions here, which we've got a few things to show you from today.
And I am Gavin Sondrup. I'm the multimedia designer here at LROC, so I do almost all of the video work, including the video that we're going to show you in just a little bit. And we are here in the LROC Community Center to just kind of show off a little bit of our exhibit. And it is currently not open, but we're planning on being open either October or earlier. So if you ever get a chance when it's open to come down and look at everything, we're going to give you a couple reasons why you definitely should do so. But definitely do so. It's super fun. You might get to see some people working and just get to figure out more about what the Lunar Reconnaissance Orbiter camera is all about.
Yeah, so we're coming to you live today from the Interdisciplinary A LROC Visitors Center, where we have one of the moon rocks from Apollo 15. We'll tell you a little bit more about that in a minute, though.
Yep, but that is the little rock that we're showing right there. We will zoom in and show it later, but to begin with, we're going to show you the Apollo 15 video that is up live on our website as well. This is to commemorate, to celebrate even, the 50th anniversary of the launch of Apollo 15, which was on July 26th.
July 26th, 1971, they launched. Yep. They landed on the moon on July 30th, and they returned to Earth about 4 days later in August. So very recent, and we just celebrated the 50th anniversary.
Yep, so without further ado, here's the video. We're going to be giving a little bit of live commentary as it goes on. And you can find this video on our website and on our YouTube channel.
Okay, Houston, as I stand out here in the wonders of the unknown at Hadley, I sort of realize there's a fundamental truth to our nature. Man must explore. And this is exploration at its greatest. 3,000 feet.
So one of the beautiful things you can see in this footage, and it was the focus of this mission, cuts through this image right here, and it's what's called a rill. A rill was carved out, it looks like it was carved out by a channel of water, because that's what we're used to here on Earth, but this one was actually carved out by a lava river, which gives it this kind of sinuous or winding texture to it, which you'll see as we turn around here.
Here you can see all the EVAs next to each other. EVA 2 traveled out the farthest distance-wise, but all three EVAs covered more path and distance than any previous mission. And in part, that is because Apollo 15 is the first of 3 J-type missions. J-type meaning that they are staying much longer on the moon. They had a lunar roving vehicle, which they used for quicker transport and to get farther than ever before. And it was just focused on longer stays than ever used in previous missions to the moon.
This particular area is called the Hadley Apennine, and that's because this Hadley rill that cuts through it. And as we pan to the left here, you'll see the Apennine Mountains. This one in particular is called the Hadley Delta.
You also get a decent view of Elbow Crater there, which we'll show more during, I believe, EVA 2? Or was it 1? EVA 1. And they traveled up right next to this Elbow Crater.
EVA 1, Station 2, I believe.
Yeah.
So that's where the lunar module landed. That was a spacecraft that they took down to the surface. And the lunar roving vehicle that they brought is actually still there today. And that's what it can see of the lunar module from when they parked it, where it still is.
There's ranging retroreflectors, which were left behind on the moon. It was part of the ALSEP experimental packages, and it's the only utility still used from those packages for experiments today. We shine lasers onto them from Earth, and we're able to determine the distance and partially the rotation of the moon from them. Now, this video is not at all in live time. Each of these EVAs took from 6 to 8 hours long, and on our website, we actually have a really cool tool that goes through in real time as they travel and what they're talking about. So if you want to learn even more, go there for sure. It's very interesting. Here you can see a panographic image that they took while at Station 1.
We include all of these photos in that temporal traverse that Gavin was talking about that shows in detail what they did kind of step by step on the moon. So if you want to walk with the moonwalker, you should take a look. Hadley Rill itself, for reference, is about a mile across from one side to the other.
Here they are on their return journey. So although it may seem at first glance that the lunar rover vehicle would allow for even farther distances than traveled, they wanted to make sure to have at least a fourth of the tank left when heading back, as well as, of course, they had to make the return journey. There was a set amount of time that they could be out by NASA, and going past that would be unsafe. So.
All of the EVAs for this mission were longer than prior ones. Well, not all of them, but they generally range from 6 to 8 hours. On prior missions, they had done, I think, 1 8-hour EVA, but that was the longest that they'd done. So this one overall saw them on the moon for a much longer time.
Part of this was due to new spacesuits that were built that utilized a much better and more efficient use of oxygen and just contained more of it, so that the astronauts could stay on the moon much longer than before.
Feature of them having the rover on this mission, they also were able to bend at the waist in these suits, which was a new feature. This particular area of EVA2 that they're looking from right now, they are actually slightly up on that hill, that Mount Hadley that we saw a little bit earlier, and it was a bit of a test with the rover.
I got a chunk about 3 inches of the rock itself.
To see how well it could handle slopes.
Yeah, so they were not sure, since this is the first time of the use of the LRV on the actual moon. It performed about as well as they planned for it. However, the rear steering during the first EVA was the only one able to be used, so they drove it around almost like a motorboat is used. But during the second EVA, they were able to fortunately get the front steering working as well.
EVA3 is especially important to us here at LROC because that is the one during which they collected this sample that we're standing next to.
This mission, or this EVA in particular, also saw them collecting the Genesis rock, which is over 4 billion years old, supposedly coming around the same time as the universe came into being, and it's just solar system, sorry, solar system. And therefore it teaches us more about the entire world than it does just the moon.
And here at Station 9A is where this moon rock was collected. This is just a small piece. You can see him picking it up there and kind of rolling it up his knee because he couldn't use both hands to pick it up. And that particular sample was roughly 9.5 kilograms, which on Earth would weigh roughly 21 pounds, a little over 21 pounds. But if you were to try and pick it up in the moon's gravity, it would have weighed about 3.5 pounds. So much easier to pick up. It's just a matter of how large the rock was.
Now
this is just a small piece.
This is just a small piece of it. Sample 15555, which is also known as Great Scott. It was the largest sample to be brought back on this mission.
We got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather, or a falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time.
He mentioned that it was a falcon feather. The lunar module behind it, they affectionately named the falcon.
That falcon feather is also still on the moon due to the limited flexibility of the suits and just not practicality of bringing it back. It is still floating around on the moon to this day.
As you can see here, they did not take back the entire spacecraft. They only took the ascent stage back. And that was actually the first time that we ever got to see the liftoff of the lunar module from the lunar surface. And it was the rover that enabled them to do that. Because until that mission, the TV camera had been tethered directly into the lunar module, which meant that it had a very short cable. And if they tried to film the ascent while they were trying to leave the moon, it wouldn't have worked very well. It would have ended up covered in dirt and probably fell over.
So if you want to go back through and rewatch that, it is of course on our website, which will be linked somewhere during this presentation. You can go through and watch the entire thing, read all the captions, because I know it goes a little bit fast at parts. But as we were saying earlier, This is part of the sample that was collected on this mission, one of the largest samples to ever be brought back from the moon, period. I'm going to see if I can get this thing to zoom in a little bit. Sorry, it's a little clunky, so that you can get an even closer view. Occasionally the lights do turn out for this thing. I'm not sure exactly what's going on with that, but we will definitely have that fixed out for you guys by October. So you can just see it a little closer. I'm just going to try to shine my phone flashlight on it to give a little bit of brightness. But that is an actual moon rock that you can come into our center and look at. There you go. The lights are turning back on. It's moving around. It's just a very, very cool part of our nation's history, as well as just NASA and space exploration history in general. So if you ever have a chance when we are open, come over and see it. It's very, very cool to see in person. We actually have an entire little exhibit in here, but you'll have to come in person and see it for yourself.
But this particular moon rock is a piece of basalt, which is a type of volcanic rock. You can actually find basalt on Earth on the ocean floor. So not the sand at the beach, but if you go way out into the ocean and drill down from there, you're going to find some basalt. And that's the same sort of stuff that a lot of the moon is made of. The Mare on the moon, all the dark spots on the moon are all made of basalt. And that's what we've got a piece of right here. Now, again, this is just a small piece of the moon rock. It's not the full thing. The entire rock itself, I believe, is somewhere like 9 to 10 inches. So it's much bigger than this. And this is just one piece. But since this was the biggest one on this mission, this is the one that they are most likely to cut into pieces to give away to people. So there's a lot of pieces of sample 15555, Great Scott, in a lot of display places around the world, including one right here at ASU. And this particular rock was named Great Scott after Commander Scott. His name was Dave Scott. He was the one with the red markings on his arms and his helmet and his knees. So you could tell the difference between the two astronauts. But he was the one who collected this at Station 9A.
He had a previous history in the Air Force, and actually during the ascent back out from the moon, he played one of the Air Force's songs that actually scared Houston into thinking something had gone wrong since he had not cleared it before, which is a really funny little fact that I like to bring up sometimes. We also have, which is very interesting.
Here, I'll hold that.
Yeah.
You get the camera. There we go.
Yeah. We've got this petrographic slide image, which is just a very, very close-up image of a portion of the sample of the rock. I know less about geology than Nicole does, so I'm going to pass it over to her.
Yeah, so this is what we call a thin slice or a thin section of rock. So we take a really, really thin piece. Usually it's a little bit thinner than if you were to take one of your own hairs and look at that, it's a little bit thinner than that, so that we can see the different colors in the minerals that are in the rock. So you can see some of them here have different patterns in the colors that they show. You can see some striping in them. But that's what we do with a petrographic slide, is we try to look at the composition of the rock specifically and see what minerals make up that rock. So this is what, if we were to cut into this rock behind us here, this is what it would look like. It's pretty darn cool.
This is just one of many images like this of this sample and many other samples that you can find online and in different archives. I super recommend just going through and looking at some of them. They're almost like modern art, just seeing all the different colors, but they appear in nature naturally. So it's just very interesting to go through and kind of just see what these are made up of and how they relate to the geology of our Earth. Also, on the ASU campus, we have other stations that have different parts of Apollo 15 that are very important, and we're going to share a couple images of those, since those are also not available to tour through, I believe, yet.
They might be. This one's over in ISTV4, right outside the Marston Theater, actually. There's a little mock-up of the rover itself. So if you want to see what that looked like, what they were driving around, it was kind of like a little dune buggy, basically, that drove around on the moon. No roof over it or anything. You didn't really need one. It's the moon. But this one in particular had a little license plate on it, and it's a very tiny little license plate. But nevertheless, it had one. It's a car. It needs to have a license plate, right? It's the only one, the first one on the moon. The later ones might have had them. But we have that license plate in ISTV4 if you'd like to come see it.
Yeah, so you can come see the actual license plate that was on the rover. It's just an extremely cool part of the history of the Apollo missions and just space travel as a whole. These LRVs have just been upgraded and utilized throughout the rest of the J missions. Apollo 16 actually utilized it in a Grand Prix that was super fun. So if you're ever interested to see that, or we'll probably be showing it in a video during Apollo 16's 50th anniversary, which is coming up this next year.
Excellent. Hey, Gavin and Nicole, I have just a question for you. So in the video, I think I understand that, of course, there was some historic video and some historic images that came from the astronauts itself, but you actually are able to create the scapes, right? The landscapes, and do that with the technology you use today to map the moon. So there's a very, very real high resolution mapping system that you're using, and then imposing the little trails and all that stuff. I think that's absolutely amazing. And so how long does it take to create that moonscape from the data that you're collecting from LROC?
For sure. It's a very, very interesting process. And actually, I'm very glad you brought that up, because while Apollo 15 is an extremely exciting mission, one of the coolest parts about being able to do videos that show even more information now is that even though these missions happened over 50 years ago, we're still able to utilize information from samples like this and from images that we are still collecting. So what happens is we have our LRO, which is the Lunar Reconnaissance Orbiter, orbiting the moon, and on it is LROC, the Lunar Reconnaissance Orbiter camera. This is a NAC wide orthographic camera that is taking large pictures, panographic images of the moon. So what we do then is we also have tools on this camera to measure heights and distances. These create DTMs, which are digital terrain maps, which we then use to be able to project them in a 3D software to build actual 1-to-1 scale versions of the terrain on the moon. So what we do is we create those terrains, and then we map the actual images that we're taking that are newer and cleaner than the ones that were taken at the time, to map them on top. And then utilizing the 3D software, we're able to use a camera to go through and show different portions of it. These images are massive. Like the ones I was dealing with were over 10,000 pixels by about 40,000 pixels for just sections of it. So it does require decent hardware to play around with. Rendering times can be quite long, but the actual time to map the DTM onto the NAC photos have already been done in major part by the LROC team. If you go onto our website, you can go through our data structures or data sets, and you can already find images and their DTMs that are mapped together. So a large portion of that work has already been done for the most part.
And then we can just go find it and visit it, right?
Oh yeah. They're available on our website under products. You're able to find all of these different sites. We have all of the Apollo sites in very amazing detail, as well as many other features. One of my favorite ones is Giordano Bruno. It's just this massive crater. But you can go onto our site, you can explore all of those, you can create your own versions. The video I made was utilizing entirely photos and videos that the public has access to, which is super cool. Although I'm with this team and I have the resources of this larger team, almost all of the products that we create, since we are a public, we're a public.
Our data has to go out to
yeah,
public.
so all of our
we all own it, don't we?
Is available.
Yeah. So it intrigues me that you can actually map the moon now better than NASA could when they were preparing for the missions. They didn't have anywhere near the detail nor the resolution. So they were flying to the moon, picking landing sites, and the new mapping technologies that you guys are bringing are far superior to what we had 50 years ago. So I wonder if astronauts ever look at this stuff and say, that's incredible. I never knew that was there. Or, I wish we had this 50 years ago when we were planning our mission, because we might have planned differently. So this, it really is, it's awesome that you guys do this work, and it's amazing that we have this technology in the air. So I'm going to actually send us to the team to see if there's any questions and things like that. And I think we have some polls for the audience. So we're not done with you yet. If you hang around a little bit, we'll get some questions going. But I really, really want to thank both of you, Gavin and Nicole, for putting this together and sharing that particular movie, a historic movie, 50 years and 1 month later, right? So from the time that they actually were there. Thank you. Thank you, guys. Alicia and Alex, how are we doing?
We're doing great. If anybody has questions, feel free to drop them in our Q&A now. And while we're doing that, I'm going to launch some polls that we have from our LROC team. The first being, what lunar mission was the first one to have a rover? 9, 11, 12, 15. The second, who were the astronauts? List many astronauts. And then the third, what mission type was this? So was it a B mission, a J mission, or a Z mission? So go ahead and vote down below, and hopefully we have some questions for Alex to ask our wonderful presenters.
Yes, we actually have one from Peyton, who asks, how do we get moon rock samples back to Earth?
Well, this one in particular, you saw the liftoff of the lunar module. And so this one came from Apollo 15, where they drove around with the little rover there, collected a bunch of samples. They put them mostly under the seats in the rover and some in the back. They've got a little storage unit back there. And then they would bring them back to the lunar module, pack them into crates, take them inside with them, and then launch the ship with them and the rocks inside it. And then from there, it was same process they used to head out. They would use to turn around and head back to Earth. Descent to the surface, all the rocks were stored in there with the humans. Since these were the only missions to have humans, it was kind of the only ones to be done that way. But at the same times that the Apollo missions were landing, actually, the Russians were sending some missions to the moon as well. Theirs were completely robotic, but they also collected some samples, which followed a similar process. The lander would touch down, collect some samples from nearby, and then launch the top part of the spacecraft, not the whole thing, but just the top part, so that way you can have more weight for the samples themselves, send them back to Earth, again, the same way they got out there, use your Delta V and your rocket to send it back.
And then another fun part about this mission in particular, Apollo 15, they brought out the largest amount of samples weight-wise compared to any other Apollo mission, which was due to just several advances in the way that they were actually handling the materials and just how they built the equipment utilized. So it was very interesting for them to be able to bring back even more samples than ever before for scientists to get their hands on and to really dissect.
All right. So if you're as old as I am, which you guys are not, but I was about, I'll give it away. I was about 13 years old when this was happening, 12 or 13. And I remember when the first samples were returning, there was lots of worry about bringing back moon germs, or, what are we going to, should we be actually bringing anything back from space? And I think there was a big protocol about sort of, putting it away and in a sterile condition for a while, and all of that stuff. So it was really, this was a big deal. A big part of these missions was being able to kind of get this stuff, bring it home, and having scientists do the work on it, like the image that you showed of the spectroscopy. So that was pretty awesome. Anyway, I just remember that being very specific. It was a lot of the talk was about the danger of bringing things home from the mission. Okay, is there another question, or should we go to kind of just wrap up the polls, guys?
Well, coincidentally, I just want to touch on two questions we just got. One's from Jeff and one's from Chris. Jeff asks, are the moon rocks radioactive at all? And then Chris actually asked, was testing done on the moon rocks to check for moon germs? So actually, just what you're talking about, how did we make sure that the samples were safe to take back to Earth?
Maybe they're also 63 years old and they remember all the worry we had back then.
Well, the problem with the germs is actually called contamination. There's forward and backward contamination, depending on whether you're bringing it from Earth or you're taking it from whatever body you go to. If it's the moon, Mars, an asteroid, bring it from there back to Earth. And there's an entire division on NASA now, within NASA, that is devoted to this. And they do focus on how to contain the samples and how to keep them in environments that won't allow things to grow. Now, most of our ideas about contamination are based on life as we know it. So, it's a little bit limited, but it encompasses most things. We do know from kind of the environment that we can see on the moon, from the Apollo missions, from some of the surveyor robotic missions that preceded them, that it was very unlikely that they would bring any contaminants with them. But just in case they did, when the astronauts came home, they and their samples would all be put into quarantine for roughly 2 weeks, as we're all quite familiar with now, before they were allowed out into the world. So that way they could see if there were any symptoms from anything, if there were any moon germs that they would bring back, they would be safe from that. So I think that
Yeah. Yeah, and as you said, contamination goes both ways. So one of the larger concerns of the Apollo missions, since they were manned missions, some of them at least, Apollo 15 was the fourth manned mission to actually go up and land on the moon, was of course the astronauts bringing their own bacteria onto the moon and how that could possibly influence or affect the different materials and environment there. And there were of course several precautions taken to make sure that the astronauts would not spread any bacteria onto the moon and that the moon would not inversely influence them. And this was also utilized in many precautions to make sure that the astronauts were not influencing materials brought back from the moon. So of course they have to physically touch them, but some of them, such as the drill on this one, use nanotubes made of, I want to say it was a, yeah, I'm not sure what the drilling tube was used, but it was a much softer, almost plastic-like material, which was much more fragile, but it didn't influence the samples that were taken from it. And the drill on this mission actually ended up breaking, but even just other samples that they were supposed to pick up, they were directed not to step on them beforehand. So there was a lot of procedures in way to make sure that there was no contamination of the samples, either physically or biobacterially, either direction. I feel like that's a little bit more than maybe you asked for, but there you go.
Well, that's right. So I think there's somebody Gavin might know that was asking a question. Is that true?
Oh.
Possibly, I don't know.
Yeah, nice.
Maybe.
We're looking into that. And while Alex is looking into that, I'm going to answer our poll questions if that's all right. So our first question, what lunar mission was the first one to have a rover? And 51% of us got that right. That was 15. So great job. Who were the astronauts? And I believe, yep, 63% of us got that right. David R. Scott, Alfred J., Warden, James B., and Irwin. I think I got those.
I do appreciate the 16 that thought Rick and I were astronauts.
I know.
That means
I think we're on Apollo 72, I think.
we should send that on our CV to NASA next time. So thank you.
That was good. And Scott and Irwin were the ones that went down to the surface, and there was always a third astronaut, the guy that had to drive the or fly the module so they could return. So always 3 in the team, and 2 of them were surface, and 1 was anyway. That's great.
And then our last question: what mission type was this? And most of us got this right at 71%. It was a J mission. So great job. And Alex,
can somebody quickly say what's a B, a J, and a Z? I don't even know this answer, so I wouldn't be able to do it.
They are different classifications of missions based on the proposal types, cost, funding, budget, also instruments X, Y, and Z. So just different levels.
Okay. And you guys knew that, and I didn't. Okay. Yeah. I guess that's okay.
All right, I'm gonna pass it back to Alex.
I'd pass it back to Rick. I wasn't able to find anything that.
Oh, I just got a note from Meg that I guess.
One open question, Alex. I think you need to read.
Okay, Alex. Oh, is it?
What's that?
There's an open question still.
Oh, there are 2. Is that from Brett?
Yes, Brett.
Okay. Then Brett's question is, what were some of the technical challenges of creating video today using images taken 50 years ago?
So there are several, of course. For one, the images that were taken are very, very well documented. However, the exact placement of where they were taken are sometimes difficult to figure out. So one of the big parts of Nicole's mapping team was actually figuring out where some of those were. And when I recreate the scene in a 3D modeling software, the distances should be exactly the same, although the units may be different because the 3D software engine sometimes uses like fake units. So finding out exactly where those images were taken to create those shots that would zoom in or angle into where the picture was taken was a bit of a challenge. Some of the videos used were shot, of course, on a DAC camera, which is a film camera. And it was not shooting at the usual 30 FPS that we're used to now. It was shooting at, I believe, 24 frames per second during this mission. So trying to get that to line up with 30 frames per second video nowadays was a little bit challenging as well. and gave me a little bit of a hard time, but all together, like putting all of them together is a fairly seamless process. There have been so many other scientists that have looked through all of this media and footage and have very, very good documentation of how all of it was taken, what it was taken on, what magazine has what. So it can be a challenge using those old images and videos to create new ones, but overall it's a really, really fun and exciting process.
But one of the advantages of using this data that is 50 years old is that it's a film camera. So you don't have to deal quite as much with pixelation problems because they are scanned very, very high resolution, even better so than the grain quality of the film. So we can actually see a lot more of the detail from those photos that they took on the moon than particularly than our NAC images, which, I mean, we can see a lot of detail in those, but we can't see the small finite things, the rocks, the smaller rocks and that sort of thing. We can see those in the Hasselblad photos, the film photos that they took on the moon. And then the other beautiful thing about it is that the landscape of the moon doesn't change that much over 50 years. You know, where on Earth you might have trees that grow, plants that change. On the moon, the craters that are there are mostly still the same over the few decades. So there isn't that many changes that we have to account for. So once you kind of get used to looking at the landscape, you can find it pretty quickly.
Thank you guys so much for the presentation and answering those questions. And it's actually just, it's wonderful for me to see people like yourselves, you know, 2 generations distant that are kind of grabbing these ideas with really a wonderful amount of passion. I can tell that you love your work. It shows, and that you're, you know, it's an honor to those people that actually did these missions and landed on the moon and did all that stuff, to have somebody generations later, you know, kind of go into this amount of detail. We're lucky to have LROC, and thank goodness we have students like you that are ready to take this on. So we'll have you back on this program more and more over the time, because there's always something new coming from the moon, isn't there?
To quickly talk about even newer things, so really fast, we've just launched our ShadowCam website, shadowcam.scse.asu.edu. I believe the link will be posted somewhere in chat or somewhere that you guys can find it. So the ShadowCam is a new NAC photographic image camera that is being put on a Korean satellite, South Korea satellite. It has just been shipped out from San Diego, I believe a little over a week ago, last week, yeah. So the website has just launched. It'll be giving you updates and information. It's planned to launch in about 11 months from now. So next year, it's 800 times more sensitive than the camera.
Oh my gosh.
On LROC.
Oh, that's awesome.
So it's going to be used to to take pictures of the poles of the moon, which are the permanently shadowed parts of the moon, and will give us even more information and content to work with. So you'll probably be seeing videos about that. But for now, the website is out. So go check it out if you're interested. And thank you so much for having us on. It's always such a joy to present.
No, you guys are wonderful. It's great to see, and keep doing the great work. That's really super. Thank you guys. All right, I'm gonna move into sort of the second part of the program, and just kind of let me share screen here. And let's see, I have to do it. Optimize this one. And so what I thought we would do a couple of weeks ago, we had a great program, and we were talking about landscape photography, astrophotography, where we have cliff faces and all that stuff. And a lot of landscape photographers love to use the Milky Way galaxy itself in the background. And the Milky Way galaxy is really important for us scientifically, you know, what it tells us about our place in the universe, and how things form and all that stuff. So it's got a great science view, but it also has a great, rich cultural history, the cultural context of how ancient cultures all over the world kind of saw the galaxy, and how we can see it today, when we can see it today. I just thought that was worth taking a look at. So I'm going to spend about 10-15 minutes kind of just flying you around a little bit. And I think some of you have seen us use this technology before. This particular system that I use for organizing and flying around the universe is called SkyScan. Digital Sky 2 is actually the program here. And we borrowed it from the Marston Theater on campus. So when we get back to campus and there's visitors, and we can get back into a theater in a real way, then you'll be able to experience this. We actually do it in 3D stereo when we're on site. But I just want to remind people that the Earth is actually floating in space. we sort of are, we have a horizon, it's always with us, and we don't always think about below the earth having stars and things being all around us, but it's important to remember that we're actually on a flying thing, and we're moving through space, and there's astronomy all the way around us. I'm going to line this up so that the Milky Way is kind of in the background there, and I'm going to just kind of like move through a little bit, and in a moment I'm going to fly out completely so we can see where we are in the Milky Way. But before I get there, I wanted to just show you some constellations and how maybe some of those constellations interact with the Milky Way itself. We are used to seeing the constellations of the zodiac. They move through our sky. We've talked about this before. The line that they follow is what we call the line of the ecliptic, which is essentially the plane of your solar system stretched out into space. So we see planets on this plane, and we always see them kind of along a line you can trace through the sky called the line of the ecliptic. The line of the galaxy itself is actually at a really great angle. It's over 60 degrees inclined from our Milky Way. So it travels through space. That particular galactic plane travels through our night sky at a totally different angle. It is more closely north-south than it is east and west. And if I sort of I'm just letting the Earth drift through this a little bit, so you can see that no matter where we look along the plane of the galaxy, we see this milky white kind of cloudy thing in the sky. What it actually is very much the combined light of billions and billions of stars that can't be resolved by the naked eye. All the stars that we see are in front or embedded in the Milky Way and very, very close to us. When we're looking at this particular sort of plane of the Milky Way as it is in the sky, we're sort of looking at the Milky Way edge on, and I'll show you that in a minute. We'll fly out and I can give you a little do that. If I add sort of the constellation stick lines, this is sort of the way ancients have put the constellations together. And I just wanted to show you that many of them interact with the Milky Way. Ancient culture handed down ideas that the Milky Way was literally for them a river of milk. This was Hera's breast milk that was causing the flow of this, and so it had lots to do with maternal themes, and also origin themes and all of that stuff. It isn't milk, of course, but lots of cultures have seen it as a river or as as something flowing through the sky. Ancient Amorins actually saw it as a path of straw, so straw that was scattered and sort of like made a path through the sky. Often it's a path. Sometimes it's a path to heaven itself. Sometimes it is the direction that birds fly in navigation in the winter. Let me just show you a couple here. So in the middle of the screen there, let me get the Earth out of the way here a little bit, so you can see. But these constellations, this is the Swan, Cygnus, the Swan, and you can see its long neck, tail is over this way, and its really long neck stretches out. It literally does look like it's using the pathway of the Milky Way to fly south for the winter. And the Swan is up in our night sky tonight. So you can see, in fact, we've talked about this on the show before, these three stars, the tail of the Swan, and Altair, which is part of a constellation called Aquila, and Vega, which is part of Lyre, make a really nice little triangle. We call it the summer triangle, and that's still visible in your night sky. You're going to see this over towards the western part of the sky after sunset. I also wanted to share a little story. We'll talk about this a little bit more in the spring, but there is an amazing festival that happens in Oriental countries, and it's kind of like a Valentine's Day. Vega represents a cowherd, and Altair over here represents a princess, and they got together, they fell in love, and the princess's mother divided them, put them on either side of the river, and one day out of every year, magpies fly in and create for them a bridge so that they can get together one day of the year. The line of the galaxy actually crosses our zodiac twice. One's kind of in the northern sky and one's in the southern sky. Let me just show you something here. This constellation, like right here, is called Gemini. And sometimes Gemini, the twins, are thought of to be standing on the Milky Way. Their feet are down in this position, and they're, the Gemini, the twins, are up here. This is Castor and Pollux is the name of the stars. So this is one place where there's an interaction between the zodiac. This is Taurus, this is Gemini, this is Cancer, and you can see how they cross essentially each other in two locations. One of them is here, and the other one is much, much lower in the sky. Let me get down there a little bit so we can see that, as I want to show you a little special thing. If you're looking across the plane of the galaxy, of course, at some point, you're probably looking towards the center of the galaxy, and that happens in our constellation called Sagittarius. So here in this particular part of the sky, here's the galaxy moving through. You can see that it's very bright down here. There's lots and lots of nebulosity. These dark spots and all this kind of stuff is a feature of the Milky Way. It's very, very difficult to see from our night sky, but if you get up into the woods, if you get away from the city lights, if you kind of go camping and things like that, you can actually see this and the flow of this Milky Way through the sky, and it's really beautiful. Right here is a constellation called Sagittarius. We sort of think of this little teapot shape, a handle and a little lid and a spout over here. I'll just point it to you. The center of our galaxy is in an area just right here. And there is a lot of dark lanes, there's a lot of things, but there is a little opening here, and scientists and researchers can kind of see into a little area. We call it Sagittarius A, a little cluster of stars in here that orbit around a black hole. So if you're looking, if you know Sagittarius, it's also in your night sky tonight. It's in the southern part of the sky, and it will be up after the show. Look for that little teapot and think about maybe steam rising out of the spout. It's upside down here, rising out of the spout here, and just outside of that little spout of the teapot is the center of the galaxy. I'm going to show you one more thing. This is really kind of fun. In Aboriginal lore and in their history, they actually made a constellation out of this dark splotches right here. It's the only time that I'm aware that a culture actually used the dark part of the galaxy to kind of create for themselves a constellation. In this case, it's an emu. Actually, I captured a little image of it. Let me just show you that here real quick. And this is sort of it sideways. So you can see, here's the galaxy moving through, and you can see these kind of dark spots. One of these is actually called the coal sack, which is a nebula that is dark and cold and opaque. And so what we're seeing there is not necessarily a hole in the galaxy, but what we're seeing there is a dark cloud that's blocking our view of the light part of the Milky Way galaxy. But you can see they sort of use this, and they have many, their Aboriginal cultures number about 250. All of them had different kinds of cosmologies and different star stories, but one that they shared quite a little bit across history and across the continent of Australia was this idea of an emu flying through the sky. If you know emus, you know they're flightless. So in this particular case, this particular emu actually had wings and could fly in the night sky. So I wanted to share that. And then very quickly, we sort of haven't left ourselves enough time to talk too much about the science here, but I also want to talk about the way scientists look at the Milky Way. And I also wanted to kind of like take you for a little ride out before we go there. So if we leave our solar system behind, we'll just sort of like leave it in the background, let us sort of drift away. Watch kind of what happens to our constellations. The way we've marked the stars from our particular location, it changes when we get a little distance. You see what's going on here? I know it's kind of hard to follow, especially on a small screen here, but that little shape in the middle of the screen here is actually a representation. Don't worry about that white and green line. Those are just artifacts of another indicator, but that little shape there represents your view of the stars. And if I back out a little bit farther, you see where your view of the stars is embedded in an island of stars. That shape sort of marks where your sun is, where your solar system is, but this is the galaxy. So what you have to remember is that we have our local neighborhood and our local view of the night sky that we get to be familiar with, and we know the shapes, we know the stories, and we know the lore of these constellations and the stars and how they operate. But we have to remember that this whole thing is actually embedded in an island of stars called the Milky Way. And if we look in any direction, right, along the plane of the Milky Way, we see the sort of the shape, the nebulosity, the dark splotches, the light splotches, and the stuff in the background that make up our sky. I'm going to show you some images that are actually not in visible light, but actually in infrared. Let me turn off our thing there for a second. And I'm going to move to just a little slightly different part of my program, but I want to just sort of show you a couple of things here. In astronomy, we're not limited to the visible spectrum of light. The sort of the colors of the rainbow, the things you know, your eye is tuned to see a very, very, very small portion of the electromagnetic spectrum. Let me show you a sort of a little bit about what that looks like real quick. And so this is visible light right in the middle here. So when you look up at the sky, the stars you see, the Milky Way, the clouds of light, the darkness, all of that kind of stuff, all happens in a wavelengths of light that your eye can detect. And you know the colors of the rainbow, right? Purple and blue and green, yellow, orange, red. This is really your visible light. But instruments, these are all the flying telescopes. Here's telescopes that are land-based and all that stuff. Instruments can be designed to read this information in all kinds of different colors of the electromagnetic spectrum. So these are different brands of energy, if you want, traveling through space and arriving at our detectors, and each one tells a different story about what its origins were. You know, what is causing all this energy to happen? What is transmitting it through space? What's happening to it on the way? You know, from where it started billions of years ago, and when we get to receive it by one of our instruments. All of that stuff is how we study the universe. And one of those, the best ways to look at that is to use these light spectrums to kind of examine the Milky Way. Let me show you this. That one was gamma rays, so in a very, very high energy part of the spectrum. This is called H alpha, and this is showing us really, really hot cloudy, energetic sections of the Milky Way. I can actually sort of just fly around this a little bit so you can see that most of that is concentrated along the plane of the Milky Way, right? That would make sense. But there are other places. This is the Large and Small Magellanic Cloud in the southern part of the sky. There are other places above and below the plane that sort of also have sort of traces of this kind of heat. So this is not looking in your spectrum, your visible spectrum, but this is looking in other things. This is actually a map of carbon monoxide. Why do we want to know that? Well, carbon monoxide is also a proxy for where we find hydrogen, molecular hydrogen. And so when you're looking at a map like this, because detectors have been trained to sort of like give us this information, what we see is in these regions that are brighter red and all that stuff, that's where we're going to find really dense areas of concentrated hydrogen gas. And that's where stars are going to form. So if you're an astronomer and you're interested in star formation, what makes that happen, what has to happen in space to make that happen, this is the wavelength you're going to look at. You're going to produce the maps of where you're going to kind of begin your search by kind of using this technology. So I love the way there's that EBU again. Look at that. I'm right there. So here's its little feet. Here's its body. Here's its neck sticking out. And its little beak is right there. I didn't mean to end up there, but that's kind of a good place to end up. And so the Milky Way lives with us in our history. It's interesting to look at. It's fun to see how people have sort of interacted with it in a cultural context over centuries and centuries of looking at the night sky. But it also offers us a really wonderful target for the best telescopes that man has made, so we can see a little bit about how things get made structurally. And I hope this has been giving you a little bit of a view of where we are and why it's important to look at some of these this way. All right, I'm going to turn us back over. I know we have another poll. We got a handful of things we wanted to make for announcements. I know we're kind of running a little long again. Sorry about that. But I'm gonna let you sort of like get out to this view. I'll stop share and we'll turn it back over to the team. Thank you, guys.
Thank you so much, Rick. Very quickly, I will go ahead and launch our second poll, which is about the Perseids, and that is Perseid meteor showers 2021. Did you look for them and see any? Did you look and not see them? Or did you just not look? So we're interested in your answer for that one.
So we made a big deal about this a couple of weeks ago. It was the peak of the Perseids. I went out 3 different nights and I followed my own instructions. I sat out there for a little bit. I let my eyes get adjusted in the dark and I didn't see anything. So I looked and I didn't see any. I have to be in that particular category. And but there are some people, look at that. So some of them actually did take advantage of this and they actually saw some. That's really super cool. I'm glad that you were able to do that. Super cool.
Yeah, it looks like about 22% of us were able to look and see some. So that's amazing.
Okay, good job, guys. We'll the next one is really cool and coming up is called the Geminids. We'll look forward to that in December. It doesn't mean that there aren't other meteor showers along the way, but we'll probably make a big deal about the Geminids because it's a wonderful show. Okay, what else do we have? I think we have some current events we wanted to talk about.
Yes, we do.
I love this little graphic. Here we go.
I know, it's great. So I just wanted to share that we still have our exhibit down and we are partnered with the Arizona Historical Society. And we have a space exhibit, the Ready to Launch. It's been running since May and it runs through the end of November. And I would encourage anybody that has the time to go down and see it because we have some great things there on display from LROC, LunaMap, our Psyche mission that we're going to be launching in a year, Phoenix CubeSat, and a lot of other things. So if you have the time, I would definitely encourage you. And I think that our team, Rick, should take a field trip and go down.
We should. And I guess we're hearing back that it's been very popular. People
are
liking
very
it.
successful
This
and
is really great.
It's going to continue. So
I love that. Good.
Yeah, so I think we should go down and so we can report back to our audience.
Okay, let's do it. We'll make it a
and
point.
With that, I'm going to hand off to Alicia because she's going to share something with our community. So take it away, Alicia.
Unfortunately, we do have some somber news to share. Astronomer Carolyn Shoemaker unfortunately did pass away on August 13th of this year. And so she was known for her discovery of 500 asteroids and 32 comets. And so, yeah, quite the accomplishment in her lifetime. And so we here at Marston and our team would like to honor her memory by talking to you about women in STEM, or just telling you that STEM is a wonderful community for people of all genders, races, social, economic status. It does not matter. And so STEM is open to any and all genders. And so we would just like to honor Carolyn Shoemaker and her memory and encourage anybody interested in STEM to look into it a little bit more.
Excellent. We use acronyms, but I think people know by now STEM is science, technology, engineering, and math. And and then I tend to kind of like to do the STEAM as well and add the arts to it. But it is amazing. And she was an amazing person. Lots of Arizona fingerprints. So Carolyn lived and her husband Gene lived in Flagstaff for years and years and years. They were associated with Lowell Observatory. And they became really wonderful residents of Flagstaff. It's a wonderful memory to have them be part of our Arizona story. And what an accomplishment. My goodness sakes, it was just absolutely amazing.
532.
We will miss her. Thank you. Thank you, Alicia. Thanks for taking that lead. All right. And then I think Alex has a couple of just resources for us to kind of remember as we talked along the way. So.
Right. Yeah. Thank you, Rick. Let me share these real quick. Okay. So we're going to talk about some resources. A lot of these are well, actually, all of these are related to LROC. The first one is just LROC's website, lroc.cc.asu.edu. This is just a great page to learn more about the moon and more about LROC and the team. You have a full about page where you can learn about the instrument and the team. You can see some of the images that has been taken, news, some of the educators that are part of the team, and for the future, once they open back up tours. Some of these additionally resources is they have fun activities like this. If you look under educators, you can actually get a lot of fun activities, videos, fact sheets. This is a coloring sheet with a lot of also interesting information. It says K8, but I know a lot of people have been getting into coloring over quarantine. So this
have you been doing this, Alex?
You know, I tried a little bit. I'm not very artistically talented, so I wasn't really that good. But you know, I would say that this is probably a lot of stuff for all ages. You can learn a lot about that. And then the final resource is the ShadowCam website, shadowcam.cc.asu.edu.
Right. And this is what we're looking forward launching in about 11 months. Great.
Right. T-minus 11 months, 5 days, 20 hours, 59 minutes, and 30 seconds. So this is another project. So once that mission goes live, this is a resource to check out then. That's our resources for this week. And back to you, Rick.
Hey, thank you very much. Well, we did sort of keep it within an hour, not bad. We're just over a minute or two. So I wanted to say upcoming in October, we have 2 programs, right? We do this every other Wednesday night. So for those of you that have been with us for a long time, thank you very much. And we still love your comments. Please send things in if there's something you want to talk about, if there's something you're curious about and you want us to kind of delve into and look into. Next week, we're going to talk a little bit about another mission called Psyche. Psyche is a really big mission for ASU. A recent article came out that just explains it a lot. We are looking forward to a launch of a Psyche spacecraft in about a year, and we'll explain all of that and the asteroid Psyche, why it's important, and all of that stuff. Also, the moon is doing some really, really wonderful things. It just happens to be in 2 weeks on that Wednesday. We're going to have one of those little crescent moons interacting with Venus, the planet, and we'll look at that. And then the moon goes on to interact a little bit with Saturn and Jupiter over the next several days. So we'll talk about that and why that happens. And then later in the month at the next one, I'm really looking forward to a discussion about a program running at ASU called Interplanetary Initiative. And our guest will be the CEO and director, Jessica, of Planetary Initiative. And she'll explain what it is and how it interacts with citizens if you're interested. And I think that'll be a great thing to learn about. So please tell your friends, keep watching. We'll be back in 2 weeks. Thank you very, very much to the team. You guys always do an amazing job. And we'll see you next week. Thank you guys. Bye-bye.